A says faster than the speed of sound. That is going to be supersonic. Supersonic speeds are faster than the speed of sound. Then we got a wave caused by alternating high and low pressure. That is what sound is. C says the organ that detects sound waves. That is going to be your cochlea. And then D, a pressure wave caused by an object going faster than sound. That is a sonic boom. So if planes are going faster than the speed of sound, when they break that sound barrier, they can get a sonic boom. And then ultrasonic, the last one, is a sound higher than humans can hear. Humans can hear sounds from 20 hertz to 20,000 hertz. All right, we got pitch. Pitch is how we hear changes of frequency and sound. Higher frequencies mean higher pitch. Low frequencies, low pitch. dB stands for decibels. Decibels is how we measure loudness. You might go to a sporting event and they might say get loud and they show the decibel reader up on the big screen. Space, what's space? Where there is no sound because of its vacuum. That is space. Loudness. What is loudness? Well, we talked about how amplitudes of the wave, if you crank up your stereo, you'd be increasing your amplitude. So right here, the amplitude or strength of sound, that is your loudness. And then this right here, it is a V with an S. Looks like this. That stands for speed of sound or velocity of sound. And in this case, that is 340, or some say 343 meters per second in the air. All right. This one here, you need to first draw the midline. You'll notice that the midline is actually going to be at the 1 mark on the y-axis, and it'd be 1 meter as indicated by the M there. So make sure you draw your midline first. That's going to help you out, because we want to know what is one wavelength, that upside down Y. Well, you can go from one crest right here to the next crest. This first crest was at 2, the second one is at 4. That is a difference of 2 meters. So we know our wavelength is 2 meters. Could have gone to 2 troughs, and you can see you would get the same answer. 1 cycle is from 1 meter to what? Well, if you're here at 1 meter, going from here all the way to the next trough would be from 1 to 3 meters. And then a half cycle if you're starting from 0. Well, right here at 0, you're at a crest. If you go to the next crest, that's a full cycle. We only want a half cycle. So go from the crest to this next trough, which would be 0 to 1. Amplitude, what's the amplitude? Well, hopefully you drew your midline in the correct spot, because you just count directly up from that. So 1, 2, and 3 meters high is our amplitude. You could also find it going down to a trough. Your answer would be the same. How many total cycles are there? We'll start from the beginning. Go down, up, back up to a crest. That is 1 cycle. Down, back up to the next crest, 2 cycles, and then you go down to a trough. So 2.5 cycles is your answer. It is a sound wave, so find frequency. Well, our formula for frequency is speed over wavelength. And so in this case, if it is a sound wave, our speed of sound is 343 or 340 if you want to make your math a little bit easier. But 343 meters per second, and then our wavelength we just indicated was 2. So you basically just want to find what half the speed of sound is, right around 170, 171.5 in this case. And we're finding frequency, so our unit of frequency is hertz. Is this frequency audible for humans? Can we hear it? Well, humans can hear ranges from 20 hertz to 20,000 hertz. So is this in that range? Yes, it is. We can hear it. Now we got a couple wave speed problems. A wave's velocity is 90 meters per second. Frequency 6 hertz. What is the wavelength? Use our wavelength formula, which is speed over frequency. Our speed is 90, and our frequency is 6. What is 90 divided by 6? Well, I'll let you guys figure that out, but it's wavelength. It'll be in meters, as indicated by the M right there in meters per second. A sound wave, that'll be important, it's a sound wave, has a wavelength of 20 meters. Find frequency. Frequency is speed over wavelength. So speed of sound is 343 meters per second, and our wavelength in this case is 20 meters. So figure out what that is. And since it is frequency, what is our unit of frequency? It's hertz. If the sound wave's frequency is 100 hertz, what's the period? The relationship between frequency and period is that they are inverses of one another. does that mean? Well, if the frequency is 100, 100 written as a fraction is 100 over 1. So if you flip it and find the inverse would be 1 over 100. And since it's period, that's like a time period, 1 over 100 seconds is your answer there. What's the above wave's wavelength? Well, wavelength is speed over frequency. So we know the speed of sound is 343 meters per second, and then frequency, we just were indicated that it was 100 hertz. Might be able to do that one in your head, but then we're looking for wavelength, so meters would be your answer there. Okay, a railroad crew is repairing a rail. You hear the hammer half a second after it's swung. How far away is the crew? Well, if sound travels 343 meters every second, how far would it travel in just half a second? So just divide that by 2 and you'll figure out how many meters it went. Similar concept here for you hear a plane 4 seconds after you see it, find the distance of the plane. Well, take the speed of sound, 343 meters every second, but 4 seconds go by. So just figure out how far it would have made it after 4 seconds. Your decibels down at the bottom, how would you hear a 40 decibel sound compared to, or how would these other ones be compared? So twice as loud as 40 would be 50 decibels. Because every time you go up or down by 10, it's twice or half as much. So half as loud of 40 is 30 decibels. Okay, and then why is space silent? Well, there is no medium. Little to absolutely no molecules up there to vibrate, so you can't get sound. If I increase the energy I give to a sound wave, what changes? That would be your amplitude. So in other words, you'd be changing how loud your sound is. Loudness. All right, and then here, draw a picture of a speaker or an ear, however you want to do that, and kind of show how the sound waves are going to spread out as they get further from the source. Let me know if you need help with this worksheet. Good luck.